Okay. Now we have some very important equations. All right. All of these are going to be very, very useful to you, and they relate to each other in a lot of ways. Okay. The first one you've seen in the top left here is that H plus times OH minus equals 1 times 10 to the minus 14. Okay. The next one is the next one in green is pH plus POH equals 14. Now you're probably familiar with pH. All right, you're probably not as familiar with POH. But we hear about pH all the time in like advertisements and things like that. And they say pH balanced for your skin and things like that. All right, and pH is a level of acidity. Okay, acidity, and POH is a measurement of basicity. Basicity. Okay. By convention, the chemistry community has decided to rate everything in terms of pH, right? But we have this relationship of H plus and OH minus. So POH is still a thing, and we can use it to solve questions, right? But by and large, we're talking about pH. Now, what does it mean to have the P, right? So anytime you see a P in front of something, that is a mathematical operation, okay? And anytime you have a P in front of something, it means to take the negative log of that thing, okay? So pH is the negative log of the H, and POH is the negative log of the OH, okay? So that's what the P means, right, is to take the negative log of something. Now, if I want to go the other way, and it's not in these slides, but if I want to go from pH and find the H plus, if I go the other direction, this log thing means to the power of 10. It's a multiplier of the power of 10, log base 10. So if I go the other way, if I want to solve for H plus, I take 10 to the power of the negative pH. Okay, so if I have the pH and I want to find the H plus, I say 10 to the negative pH. And then I can do the same thing with the POH. I can say the OH minus concentration is 10 to the negative POH. Okay? So all of these equations are going to be useful to you, and I recommend that you write them down somewhere right now. Okay? So perhaps pause my video and write down all, 6 of these equations somewhere where you can refer back to them. Okay? Because we're about to do a whole bunch of problems using these equations. Okay? And that's the majority of the homework too, is doing this type of work. All right, so let's start with this table. Okay, and what I'm going to do is I'm going to scroll down to a blank sheet, and we're going to work through solutions 1 through 4, okay, and solve all of these things for all 4 solutions. Okay, so like I said, if you need to, make sure you have these equations written down, because we're about to use all of them in some way, shape, or another. Okay, so actually before we go, I'm going to explain something about our first equation up here top. So H plus times OH minus is 1 times 10 to the minus 14. So if I want to solve for H plus, all I have to do is divide the OH minus to the other side. Okay? And vice versa. If I want to know the OH minus, I just divide the H plus to the other side. Okay, so that's the main place that equation comes in handy. Okay, so let's tackle this thing. So starting with solution 1. Let's go to black. Okay, so with solution 1, let's see what we're given. We're given an H plus concentration. Okay, so H plus of 10 to the minus 6, or 1 times 10 to the minus 6. And that's molar, okay? Remember, we're talking about concentration and its molarity, okay? So if I want to know, the first thing that it's asking me for is the OH minus. So I can use the relationship of H plus to OH minus and solve for that. OH minus equals 1 times 10 to the minus 14 divided by H plus. So 1 times 10 to the minus 14 over 1 times 10 to the minus 6. And I'll remind you, use your parentheses so that your order of operations don't go awry. And we should end up with an answer that is 1 times 10 to the minus 8 molar. Okay, because remember, we're talking about concentrations. You need to remember your units. Okay, so the next thing it wants is the pH. Okay, and pH is negative log of the H, and we were given that in the beginning of the problem. So pH equals the negative log of 1 times 10 to the minus 6. And you type it into your calculator exactly like that. You hit the negative button, you hit the log button, and then you type in 1 times 10 to the minus 6 and hit enter. Okay, and we get an answer of 6. And then the last thing that it wants is the pOH. And the pOH I can find from the relationship with pH. So it's 14 minus the pH. So 14 minus 6 equals 8. Okay? So we should have the OH is 10 to the minus 8 molar, our pH is 6, and our OH is 8. All right? So let's go ahead and make some room. And let's do solution 2. All right, so solution 2, we have the OH concentration of 2.3 times 10 to the minus 8 molar. All right, so if I want to know the H plus, I can say 1 times 10 to the minus 14 over the OH. Divided by 2.3 times 10 to the minus 8. And when we compute that little beauty, we get 4.3 times 10 to the minus 7 molar. Okay? So the next easiest thing is the pH. The pH is negative log of the H plus, and now that I know that, I can compute that. And remember, this is the H plus. And we get an answer of 6.36. Okay, and I'll talk about sig figs here in just a minute after we finish this stuff, because the rules for sig figs and logs are a little bit tricky. Okay, so since I know both the OH minus and the H plus, I'm going to calculate pOH a different way. Now I could just say 14 minus the pH to get the pOH, but I'm going to show you that there are multiple ways to go about this stuff. I can calculate the pOH the same way I did the pH and say the negative log of the OH. Okay, this is the OH concentration. And we find that that is 7.64. Okay, so let's go ahead and fill in our table here. So the H plus was 4.3 times 10 to the minus 7. And our pH was 6.36, and our OH was 7.64. And we can actually check our work with that. If I add those two numbers together, the pH and the pOH, it should equal 14. All right, so next. So now we're on solution 3. And solution 3, we're given pH of 11. So the easiest thing is to find the pOH right off the bat. So pOH is 14 minus the pH. 14 minus 11 equals 3. Right, so that one's easy. So then my H plus, so I can go backwards through the pH calculation, and we say H plus is 10 to the negative pH, right? So 10 to the negative 11 is the same thing as 1 times 10 to the minus 11 molar. And then we can do the same thing with the OH. We can go backwards through that. 10 to the negative pOH. So 10 to the negative 3. 1 times 10 to the minus 3. All right. So our H plus is 10 to the minus 11. And our OH is 10 to the minus 3. And our pOH is 3. All right. So that set of 6 equations, we can really get a lot done with them. All right. So let's look at our last one, our solution 4. And there we're given the pOH of 3.3. Okay, so the easiest thing is to go right to the pH. Say pH equals 14 minus the pOH. 14 minus 3.3 gives us 10.7. Okay, and then just like we did in the previous problem, if I want to know the OH minus concentration, is 10 to the negative pOH. In this case, 10 to the negative 3.3. It's going to equal 5 times 10 to the minus 4. Okay, and again, that's an issue of sig figs, and I'll explain that next. Why it's only one sig fig. 10 to the negative pH to find the H plus. So 10 to the negative, what was the pH? 10.7. And that comes out to be 2 times 10 to the minus 11 molar. All right. pH was 10.7, and the pOH is 3.3. So let's see how we did.